Hi there, this is Mr. CB, and we're going to be doing another lesson on MOS. So what is MOS? It is modeled output statistics. It is just basically a way that we're going to get some data. It can be displayed through MOS. It is being phased out. It will probably exist for a few more years. This video is being made almost in 2026, and so it might not exist in a few years, or probably won't, but it a lot of components of this are incorporated into NBM that we'll look at in the next lesson. But it's basically just statistics that's applied to raw data. So we have raw data coming from the models, and these statistics are applied, and we're getting these values. It's just going to be a series of numbers, and we're going to go through how to read it. This is better for subtle changes. Whereas if you're just looking at raw data, that's going to be better for rapid changes because the statistics are going to be off if it's like a rapid change of um, what's going on. It's ran through GFS and NAM, and it's going to interpret the models based on historical samples. So, looking at data of what's happened before, let's apply these statistics to the data to figure out what we might have. Things that are out of the norm won't work well, like I mentioned. If it's a unusual situation, it's going to be slightly inaccurate. And it helps to correct for some model biases because the different models that we have will have biases. Okay, so let's look at some of the predictors. Okay, so predictors. Um, the predictors are going to be the data that's brought in. The predictands are the changes that we'll see, or basically the data after the statistics are applied. We're going to get this data from the NWP model forecasts, prior surface observations, and geoclimatic information. Some of the statistics methods that are used involve linear regression. We don't really need to know the specifics about that. Strengths, like I said, it helps correct model error or bias, applies to local effects, used in routine weather events. We can have two situations. Um, we can have MAV, which is going to be operated short range at 0Z, 6Z, 12Z, 18Z, up to 72 hours of coverage. Extended range MEX is going to be offered only at 0Z or 12Z, up to 194 hours. So let's read this thing. Okay, I gotta move my stupid. Okay, I'll just put it right here. Um, so let's go through each of these rows. This is slightly boring, but useful to know. Um, so it's really not hard, but you just have to know what the things mean. But usually it's somewhat self-explanatory. So the top row, the first letters that you see, KOGB. That is your station identifier. It typically begins with a K and then the three-letter identifier, which in this case represents Orangeburg, South Carolina. Um, I do not, I'm not based out of there now, but I was when this channel began in 2019. Okay. Um, Came from the GFS. You can see that. MOS, yes, we know it's MOS. Guidance, yeah, it's MOS guidance. 1209, 1225, or 2025, sorry. It's 1:57 a.m. when I'm making this, just to let you know, so kind of tired. Um, it's December 9th, 2025. Cool. Zero's UTC, Zulu, okay? Well, really what this means is that when this screenshot was obtained, when I made this, you go back 5 hours. to know the time that it is um, in Eastern. So that really means that this would have been from, if you say, okay, midnight, go back 5, that's 7 p.m. Um, so that this was from 7 p.m. really yesterday. Uh, but nevertheless, let's move on to the next row. DT, date. It, you can see that it goes up to December 11th, which is Thursday. Forecast hour is what the HR means. And you can see it's operated at the first hour that it shows is 6Z. Then there's 9, 12, 15. It's 3 hour increments in this case. Next row, XN, X slash N. Um, it could be N slash X if you have, this is a case of MAV. We could have a case of MEX. But regardless, it's self-explanatory to know that this is the max and minimum temperature in Fahrenheit for the day and the night. So we can see 47, then down to 29, high of 58, low of 39, then 53. And you can see that when they happen at 0Z and 12Z, and it doesn't mean that that's the exact time that it will occur. And as you can see, that actually really isn't what they'd expect, but it's just listed at those exact times, but that's not going to be when exactly it is. As you know, it's not going to be exactly at midnight and noon when we have the high and the low. It's going to be right before sunrise that it's the coldest in the day, and right before sunset that it's the warmest, typically, unless there's some frontal. You don't even need to say that, but in most cases, that's just the diurnal processes. Okay. Um, TMP, surface temperature, and Fahrenheit. Pretty self-explanatory. DPT, dew point, and Fahrenheit. So obviously, if you know that those temperatures are closer together, um, more moisture that we might expect. CLD represents cloud cover. There's 5 possibilities. CL, clear. That means no coverage. FW, 1 to 2 octas, and octa is just a unit of cloud coverage that we'll use for cloud coverage that can go from 0 to 8. 8 is the most coverage. So 1 to 2 octas for few, ST scattered 3 to 4, BK broken clouds 5 to 7, and then OV overcast. In this case, you can see there's just SC, BK, SC, CL. It's mostly not that much coverage for Orangeburg in the next couple days. Next, wind direction in degrees. So 90 degrees is going to point east, 180 south, 270 west, 0 north. Okay. You add a 0 to these numbers. They can't just put so many numbers on here or it'd be terrible to read. So 02 means 20 degrees, 18 means 180, and of course it's where it comes from. Remember, always where it comes from. Wind speed in knots is the next row. P06, the probability of precipitation um in the 6 hour period. And as you can see, very low. Um, only 1%, 0%, 3%. And to tell you the truth, sometimes when you see a 1 or a 2 or really low numbers, you really can just assume that it's a 0. It's just a slight variance. It's difficult sometimes for it to be exactly 0 based on the statistics applied. So you might really just assume that it is 0% at the times when it says 1. 12 hour is what that's what P12 is, the exact same thing, but it's just 12 hour period. Ending in the hour too. That's something I meant to say. It's ending in the hour. So now the Q T06 and Q12 represents QPF, which stands for Quantitative Precipitation Forecast, which just means the liquid equivalent of precipitation that we might expect. So if you were to melt down, if it's something that can be melted, if you were to melt it down, what would the liquid equivalent be? Because that's not always going to be the same as what it is for solid. We have some, thermodynamic processes that's beyond my um, qualifications or to explain exactly how all that is. But when you have to make sure that you know that it's the liquid equivalent um, of what precipitation that we have. But there's all zeros in this case, so there's not expected to be any uh, actual QPF for Orangeburg in the next couple days. But it's not going to be that it's important to note for Moss for this, it's not going to be the number that you see isn't the amount, it is basically a category. 0 through 6. So 0, no precipitation, and then you can see 1 through 6, it's differing amounts. Like it's not exactly crucial to memorize these. That's kind of crazy, but it would be important, of course, to know that 6 is the maximum, and it would be 2 inches or greater. Because remember, if it was anything more than that, really moss wouldn't be necessarily useful. Well, it could be, but in cases where we had extreme QPF, maybe it would be some kind of unusual event. And like I said, you're not going to want to use this for those situations. T06 and T12 represent um, we see two values separated by a slash. The probability of thunderstorms slash the conditional probability of severe storms during this 6 or 12 hour period. Now you can see in this case, we have almost all zeros for probability of thunderstorms, but for the conditional probability of severe thunderstorms, we do have values that are non-zero, but still not very high at all. The highest that you see is 20, and that's just from a 12-hour period. Next, POZ represents the probability of freezing rain valid at that hour. That's obviously important because freezing rain would be um, dangerous, is dangerous. And I will say one thing, I happen to be in an area right now that is experiencing some freezing rain, so I'm not driving. I'm in the comfort of my home at 2 a.m. making this video, not in any public building like I might prefer, but that's because I'm not hoping to crash my car. So if I pulled up where I am, it's not going to be zero. Well, it might be in the future, but at least in past Moss. But you can see that there's one, you know, that's really a zero. Don't think anything of it. I mean, 1%, you know. Um, what? Okay. Well, well, well. For some reason, I skipped that, but that is the POS is probability of snow. So it's like the POZ. And in this case, surprisingly for South Carolina, it's not that common, but there's actually 60%, as you can see at the 12Z December 9th. We do see a temperature of 33 degrees, dew point of 28. So it's in the realm of possibility, but um, as you might know, that sometimes it can be slightly inaccurate, so it's not really common at all, but there could be some minor snowfall, but wouldn't have any accumulation based on what we saw above. Um, TIYP is like type of, it's the conditional precipitation type at that hour, and it could be R, S, or F. R is going to be a liquid situation, rain, or sometimes even a little bit of snow mixed in with the rain. But if it's mostly just liquid, it's R. And it's when we say conditional, it's like basically we're saying it's not going to do that. It's if there is precipitation, this is what it would be. S is snow. So you can see that there would be snow if there was precipitation at that time. F, freezing, any kind of freezing, icy type of precipitation. Snow, S and W, is the snow forecast, and for South Carolina, no surprise, it's going to be zero. But of course, in other situations, like where I am right now, that's not actually what would have been the case in the recent times. And you can see a value 0, 1, 2, 4, 6, 8, and that is an interval actually. So important. That doesn't mean that's what the inches is, it's the interval. So see that there. SIG or CIG, sorry, is the ceiling height. And it's in feet, and once again, it's not going to be the value, it's going to be a categories of values. Um, we will see a difference in the next video, and because as it turns out for the general public, it's not as easy to comprehend these um, just categorical numbers. So you'll see though next. Visibility. In statute miles, we can see once again it's categories, but in this case we just have 777 because it's just basically maximum. It's like visibility is good. Then the last thing is OBF or V. I'm sorry. I don't know my alphabet. I keep saying the wrong letters. OBV. That doesn't even look like F. But anyways, that's the obstruction of visibility. So if there is any visibility issue, what could it be? N, nothing. So if you see sevens, N's is what you'd expect. But in other cases, you could have HZ, haze, smoke, or dust. BR, mist. We could have some mist. FG, fog. Um, BL, blowing dust, rain, or snow, or sorry, sand or snow. I've never been in a case where you would have sand, but that could definitely be a situation. And that's it. So, thanks for watching and learning about moss.